Bismillahirrahmanirrahim. Okay. Assalamualaikum and very good evening to all of you. Welcome back to the class. In this video, we will discuss about the example 3.1 of stairs with landing and continuous at one end. Okay. In this example, you have to design a staircase for office use as shown in the figure E3.1. It is connected to a landing at the upper part and supported by a beam at the end of the landing. At the lower end, the stairs is supported by a beam and continuous with the floor slab. Okay. At the up, okay, sorry, connected to the landing at the upper part. Okay, this is landing, and then supported by a beam at the end of the landing. Okay, this is maksudnya. The mean is it is at the upper part of the staircase. This is okay. Upper part means here. At the upper part, it is supported by the landing. Okay, this is the landing, and the land and supported. Okay, and supported by a beam at the end of the landing. Okay, and at the end of the landing, it is supported by a beam. And then at the lower end, the stair is supported by a beam and continuous with the floor slab. Okay, means at the lower end, this is lower end. It is supported by the beam, and then this is a slab from floor. Okay, floor slab lah. Okay. Okay, they design the staircase by using concrete grade 30. And strength of reinforcement is 500 Newton per millimeter square. The imposed load is 400. Sorry, the imposed load is 4 kilonewton per meter square, and the finishes is 0.5 kilonewton. It's all kilonewton, kilonewton per meter square. The nominal cover here is given as 25 mm. The width of the stairs is 2,500 mm. The thickness of landing is 150 mm, and the waist thickness H is 150 mm. Design the reinforcement, use the bar 10 mm. Okay, so this is the detail of the beam. The going is 250, the riser is 170. This is the waist. Okay, and then the given value of T, okay, the thickness is 150 mm also. Okay, and this is the specification of the design. The concrete strength, okay, grade 30, the steel strength, and then the imposed load, finishes, steel nominal, okay, width of the staircase. This is shall be, okay, this is width. Is it width? This is G, G is going. Okay, width of the staircase is shall be 150 actually. Okay, but it's okay. It shall be 150, or it shall be one. This shall be one actually. The width of the staircase. I don't know why the staircase is too long. This shall be one. Okay, 1.5 meter only 1.5. 1,500 mm. Okay. Thickness of landing. Okay, this is H. Okay, diameter is 10. Okay, and this is the thickness of the flight. Okay, we can use this. Okay, this is the thickness of the flight. This one from. Okay, from here, from this point to this point is the thickness of the flight is Y. Is equal to 1 at 1.5 mm. Average thickness is, we use these equations as 244. Sorry, G is going. Okay, G is going. R is riser. Okay, 266.4 mm is the T. Okay, this is the given H waist. Okay, this is average. Okay, yes, average thickness T. So this average thickness means like this one. This is here average thickness. Okay, we take the average, so we can the average thickness, so we can consider the which enable us to determine the safe weight later. Okay, so for the landing, safe weight is equal to this one 0.15 times the density of the concrete, and then okay, this is because this is the landing. Okay, here is the landing. Okay, we just take the thickness 150 mm or 0.15 meter, and then okay, this is the safe weight of the landing, and this is the finishes. So then the GK we get as 4.25 kN/meter. The variable actions is 4.0 kN/meter square. So we use this equation. We get the actions on the landing as 11.74 kN/meter square. And then for the flight, okay, we use the similar method. We calculate the safe weight of the slab, and instead of 0.15, we can use 0.266 because this value of 0.266 here is come from here, the average thickness of the flight. Okay, average thickness. Okay, and then this is the finishes. Okay, we total up, we can get the total dead load GK, and then the variable action is 4.0 kN/meter square. We use this equation, and then we get the design action is equal to 15.65 kN/meter square for flight. Okay, and then for the design of main reinforcement, so this is the illustrations of our loading arrangement. So this is for the flight area, and then this one is for the landing area where the loading is lower compared to the flight, and then this is the distance. And then but you must remember the support is at the end of the staircase. Okay, at both end here, because this is, we have the beam here at the lower end supported by the beam, and then at the here first the flight is supported by the landing, and before being supported by another beam here. Okay, so we can here see that this is the distance, is the landing is 1.4 meter, and then the flight is 2.5 meter. 2.5 meter, and then this one is 1.4 meter. So we take a look here. Okay, first of all, we get the total load F here. To determine the total load is the loading times the distance. So we get the point load here, and then 11.74 times 1.4, we get another point load here, and the total is equal to 55.561 kilonewton. The unit is kilonewton. And then as I mentioned in our lecture sessions, okay, the bending moment can be determined as M is equal to FL over 10. So this is okay, the F is in already multiple. We already consider the distance, so just put it here. The F is here. The total length is L equal to 3.9 meter, and then over 10. So we get the bending moment is 25.67 kN/meter. Maximum is here at the bottom. And then so we can calculate the effective depth. So because our design as we design as the just like the procedure of the slab design. So this is the, they say this is our our staircase, and then we want to design the reinforcement. Let's say reinforcement is here. This is the, sorry, I must make it larger. Okay, this is the main reinforcement here. Okay, and then this one is this is the secondary. Okay, secondary reinforcement, we don't have to calculate the bending moment. Okay, we don't have to calculate the bending moment. The red color is the main reinforcement. So you must calculate the D is, okay, from the average, from the average, from the H. Okay, this is, okay, the H. This is your C nominal, and then this is, okay, the average thickness is, we use the average thickness to determine the average thickness of 0.266 meter is we use to determine the safe weight of the slab. Okay, but for design we use the given thickness, okay, which is 150. So the C nominal, so 150 minus the is equal to 150 minus C nominal, and then minus, okay, this is the center of the bar. This, okay, here to here is center of the bar is equal to the diameter of bar divided by 2, and then we got the D is 120 mm. So we just put it in this equation. So we take the value of B as, okay, this is the B is equal to 1000 because we design for every 1 meter width. Okay, just like the slab. And then we compare to the K balance. So the compression reinforcement is not required. And then we determine the value of Z. We determine the value of AS. This is the AS. We open the table as I show you in the reinforcement slab design. Okay, here. Reinforcement. Okay, sorry. Table of reinforcement. Okay. Okay, this one is table of reinforcement. Okay, it shall be, okay, for the area of C required is 436.98 millimeters square. So we provide H10 because we use based on, okay, we determine the D based on diameter of bar is equal to 10. So you must use 10. If you determine based on diameter of bar, if the diameter is 12, so you select based on 12. Okay, so we need is here, we need the reinforcement of 436. So we provide 175. So let's check. Diameter here is 10. And then 175 is here, so 449. Okay, and the spacing is 175. Okay, okay, so it's true. So we check the minimum and maximum reinforcement area. So 449 is still within the range, mean it's okay. And then the secondary reinforcement. Okay, the secondary reinforcement here, okay, this one is secondary reinforcement. So we don't have to calculate the bending moment for it. We just use this rule, which is the equal, okay, which is equal to 20% of the AS. Okay, so the AS is a provided one. Okay, the provided one is 449 here. So 20% is equal to 89.8. But however, we must fulfill the requirement of minimum and maximum. So 89.8 is lower than minimum, so we must increase the value. So let's say we must we choose H10 at 450 here. Okay, H10 at 450, it will give 174 or 175. It doesn't matter. Okay, just a small difference. Okay, so we provide this one as means H10 for spacing of 450 as the okay, the spacing here letter is 450, but we have to check for the crack letter, either 450 is enough or not. Okay, the spacing is 450 for secondary bar. And then we check for the shear reinforcement. For the shear is okay, you must recall back your knowledge during your theory of structure subject. Okay, how to determine the RA, how to determine the RB. Okay, the reactions. Okay, the reactions is equal to the shear. Okay, okay, so you determine the RA and the RB, and then we check the shear resistance. Okay, shear resistance for the concrete. Okay, here this is the shear resistance of the concrete. It means the capacity of concrete to cater for the shear, and then this is equal to 85 kilonewton, which is greater than the VED. Okay, the VED is equal to the maximum between RAO, RB. We take the maximum one, which is 29. So this is our shear force. Okay, so the shear force is equal to the reaction of the support. So is once it's greater than 29 for greater from the shear force, so it's okay. And then we check for the deflection, okay, as usual, okay, based on this clause in Eurocode, and then you use the equations. We just multiply the value inside the equations, and then we compare between the actual and the allowable. If it's okay, okay, which if the actual is lower than allowable, then it's okay. And then we check the thickness, okay, thickness. Okay, for cracking, the slab thickness, okay, let's say less than 200 mm, and then the main bar for the spacing, okay, spacing of main bar is less than 3H, okay, or must be maximum of 400 mm. And then our actual spacing here is we use this one, okay, 175. So the spacing 175 is lesser than 400 mm, so it's okay. And for the secondary bar, the limiting value is 450, and we propose here is 450, which is still the limit. Okay, here the proposed value here is still within the limit, means it's okay. Okay, and then we provide the detailing. So this is the detailing for the reinforcement. Okay. Okay, and this is the what we provide here. This is number one. Okay, what the number one is here, the main reinforcement H10 175. Okay, let's say I make it as a blue color. So this is the main reinforcement. Okay, here main reinforcement. Okay, the blue color is the main reinforcement. We calculate, we determine from the bending moment, and then we provide up to here. Okay, this is how we install the bar here, and then at the support we must provide this color, let's say, as I mentioned before in the lecture, a similar distance and similar diameter. Okay, so this is number 2. So the number 2 is here at the this one is a bottom, and then this is a top reinforcement at the support. We must use a similar diameter and similar spacing. Okay, and also here top at the support. Okay, and then we use the secondary reinforcement. This is how to mark. This is how to mark. Okay, we use, let's say, the green color here. This is the, okay, here the spacing is equal to 450. as we calculate. Okay, this is the secondary. Okay, okay, this is the secondary support, secondary reinforcement, which is number 3. So I believe you can start by tonight. After having this tutorial, you can finish the design of your staircase for your project. Okay, you can use the dimension. Okay, just find the dimension. What is the dimensions? Where where I mean the, okay, you determine your half. This is your half height, 170. Let's say this is your house. For your project, this is the beam. This is the beam. Okay, this is your landing. Okay, and then this is another. This is the another landing. Let's say, and this is the landing beam. So you just design. Okay. Okay, let's say, okay, so you must determine. Okay, you must determine your going and rise. Okay, what is the value of going? What is the value of G going, and what is the value of R? And then you can determine the average thickness in order to calculate the bending moment and the shear force. So this is okay. Can you imagine? So this is another half of your staircase. Let's say you can design your staircase as this example. Okay, which means like this one. Okay, you can first, you must illustrate your staircase, the cross section of your staircase. Let's say this is your beam at the lower level, and then this is the beam, landing beam, and then another one here. So you must, if your building is 3 meters, so this one is going to be 1.5 meters. Okay, divide by 2. Just divide by 2, and then you can do the design. It's very simple. Okay, just divide by 2. Let's say your building, floor to floor height here. Let's say your building here is okay, 3 meters. Okay, 3000 mm. So you divide here to here is about 1.5 meters, and then you can start do the design. You can follow this example actually. Okay, and make sure your value of loading refer to the code. What is the value of imposed load for the staircase? Okay, I hope you can do it, and see you later in our next video, where I will discuss about example 3.2, where the stair is supported by landing. Okay, class, thank you very much for your attention. See you in next video.